Hello, everybody. In this video, we are going to develop an LMC program that accepts an indefinite number of input values, and the output will be the largest of the input values. You should use the value 0 as a flag to indicate the end of the input. So this is the logic for finding the largest of many numbers. Consider that we need to maintain the x that is the current largest, and then every time we are taking the input a. The moment we take the input a, we want to check if the input a is equal to 0. If it is true, then we are coming out because we want to continue only until 0 is entered. Otherwise, we are supposed to find out if the x is largest or the a. So a minus x is greater than or equal to 0. If we consider this condition, it will tell us if it is positive means the a is largest. But if it is not, then x is largest. Then we look forward. So suppose a is smaller, then we look forward to the next input. Suppose a is larger than x, then we replace the value of previous x, which is initialized with 0 first, with the current largest value. So now x has the largest value, and then we take the next input. The next input we take, and then again we go through the same procedure, checking if it is 0. If it is 0, we are supposed to give out the output of the largest, which is x, and then close or hold the program. But if it is false, means a has something else, not 0. And that's how we again go for the next check, that is a minus x is greater than 0. All right, so this goes on and on until the user types 0. The moment user types 0, this becomes true. You give the output of x and we hold the program. So let's code this in LMC. So we have here LMC. You can use your student ID, and then I can start coding here. So it tells you this is a default program when you start a program. So I can start a new, right? And it gives me this. And now what we need to do is we start coding. We will follow the same logic here. So first we will define the data, and then we take the input A. So for that, I'll start. Now we can see from this figure that input A is every time referred, and we have to come back here. So let us define a label which can be referred once the condition false. So here we are going to define input A as a label, and we are taking the input. I'll just extend a bit so that it's visible. And now we want to store it, but we don't have the storage yet. So first let us define the storage, define the hold, and then the data section. In the data, we need to exactly the values which is playing around the algorithm, that is x and a. So let us define both of them. We define a. Now we have defined the data section, and now we can proceed to store what is taken as an input. So we store it as a. Now we check, because the very first condition that checks is if a is equal to 0 or not. So for that, we are going to use BRZ. If it is 0, then we should travel to some other place. Over is there, and now I will define the over and what I want to do in over. So what I want to say is if it is 0, what I should do, I should output X and then come out. So for that, I need to load X, give it out, and then halt. So this is done. Now, suppose it is not 0. If it is not 0, we check for the next condition. That is A minus X is greater than or equal to 0. But we don't have, so we don't have here the value of A. So we need to find out if we need to load A. Why? Because we wanted to check if it is over or no. So in that case, we will do, but here the accumulator has taken the value of input A, and that is what is just checked if it is 0 or no, right? So then we have our accumulator ready with A, so I can directly check for subtract X. And then I want to check if A minus X is positive. So for that, I need to use the condition BRP, not Z, right? Because we want to check if it is positive. If it is positive, what do we do? If it is positive, A is larger, then we replace the X value with the A value, and then we go for the input. So let's do that. So if it is positive, then you go to the A is large, right? But we don't have where A large. So define A large. What do we do in A large? We load the value of A because in the accumulator just now the value is A minus X, right? So we load A and then we update our X by storing the accumulator value to the X. And finally, we go and take the input. So unconditionally, so branch in. So jump to the place without checking the condition. That is, take the input. Where is it? It is here, input A. So we'll call input A. Right? Thereafter, what is to be done? If it is false, what is to be done? So suppose it is false, means A is larger. Right? So in that case also, the same thing is happening. Right? So unconditional branching will happen, and then the control comes here and it goes on and on. So let's cross check it. We are taking the input, we store A, we check whether it is over, we subtract X if it is not large, right? And otherwise, suppose A is not large means it is less. It means X is larger. Then what is to be done? Take the input. So branch unconditionally and shift your control to A input A, right? Now A large, we are loading the A, storing it as X, and then again taking the input. And then once everything is over, the value is equal to 0, load the largest and give out and hold, right? So I think this should work. And so let's try it. So for this, what we want to do is we want to save it. So save as, and we can save it as largest of all, right? And now we run it. So it's asking us for input. Now if I give 0, what happens? Does it come out? Yes, and the output is 0. So this condition is working, right? Now we need to check the different value of A. So now I'm checking the 10. So my A has 10 and my X also has 10. Now I'm giving 20, right? So my A has 20 and X has 20. Now I will give 15. So my A is 15, but X stayed 20 because it's smaller, right? Now I'll give 0 so that it should print 20, not 15. And it prints 20, so the program is running fine. So this is how we have learned how to code an assembly program for largest of many numbers following this program and this logic.